I am Jaysha May Canedo and I'm going to report about lipids and lipid system. So, lipids. Lipids are a diverse group of organic molecules that play crucial roles in the human body and are of significant interest in pharmaceutical biochemistry. They include substances like fats, oils, phospholipids, and steroids. Lipids serves various functions such as energy storage, cell membrane structure, and as signaling molecules. In pharmaceutical biochemistry, lipids are important in drug development and delivery systems, as they can be used to encapsulate and transport drugs in lipid-based nanoparticles or liposomes, enhancing drug solubility and bioavailability. Additionally, lipids are a target of research for developing drugs that affect lipid metabolism and related diseases, like hyperlipidemia. The biosynthesis of lipids often involves a transport and shuttle system to move lipid intermediates between different cellular compartments. This system facilitates the assembly of lipids in various organelles, such as the endoplasmic reticulum and mitochondria, where different lipid components are synthesized and then transported to their final destinations for further processing. Overview: Lipid biosynthesis, also known as lipogenesis, is the process by which the body synthesizes various lipid molecules, including fatty acids, triglycerides, and phospholipids. This process is essential for energy storage, cell membrane formation, and the production of bioactive lipids. In pharmaceutical biochemistry, understanding lipid biosynthesis is crucial for drug development and the management of lipid-related disorders. Lipid biosynthesis refers to the complex set of biochemical pathways by which cells create various types of lipids. These pathways include the synthesis of fatty acids, phospholipids, triglycerides, and sterols like cholesterol. Here's an overview of the lipid biosynthesis pathway. First is the fatty acid synthesis or de novo lipogenesis. It occurs in the cytoplasm, begins with the conversion of acetyl coenzyme A into malonyl coenzyme A. Enzyme fatty acid synthase plays a central role. Repeated condensation of malonyl coenzyme A with acetyl coenzyme A to form long-chain fatty acids. Fatty acids are important components of triglycerides and phospholipids. Phospholipid synthesis. It involves the addition of phosphate group to diacylglycerol, and this forms phosphatidic acid, a precursor for various phospholipids. Phospholipids are crucial for cell membrane structure and function. Triglyceride synthesis. Triglycerides are formed by esterifying glycerol with three fatty acids. This molecule serves as a major energy storage form in adipose tissue. Sterol biosynthesis, or cholesterol. Cholesterol is synthesized primarily in the endoplasmic reticulum. Mevalonate pathway is the key pathway for cholesterol synthesis. Cholesterol is essential for cell membrane integrity and serves as a precursor for steroid hormones. Regulation of lipid biosynthesis. Lipid biosynthesis is tightly regulated by cellular demand and feedback mechanisms. Hormones like insulin and glucagon play important roles in regulating lipid metabolism. ATP, citrate, and malonyl coenzyme A levels also influence the process. Structures, functions, and classifications of lipids. Structures. Fatty acids. Fatty acids are long hydrocarbon chains with a carboxyl group. They are the building blocks of many lipids. Triglycerides. Three fatty acids attached to a glycerol backbone. They serve as energy storage molecules. Phospholipids. Composed of glycerol, two fatty acids, a phosphate group, and a polar head group. They are crucial for cell membranes. Sterols, a ring-like structure such as a cholesterol which is essential for cell membrane integrity and act as a precursor for steroid hormones. Functions: energy storage. Triglycerides store excess energy in adipose tissue and can be metabolized for energy when needed. Cell membrane structure. Phospholipids are vital components of cell membranes, forming the lipid bilayer that controls the passage of molecules in and out of the cells. Insulation and protection. Lipids in adipose tissue provide insulation and cushioning for organs. Signaling. Bioactive lipids like prostaglandins and sphingolipids play crucial roles in cell signaling, inflammation, and pain regulation. Hormone production. Steroid hormones derived from cholesterol regulate various physiological processes, including metabolism and immune responses. Classifications. Simple lipids, comprising triglycerides and waxes, which are primarily involved in energy storage and water repellency. Compound lipids. These include phospholipids, which form cell membranes and are essential for cellular structure. Derived lipids. Derived from simple and compound lipids. This category includes bioactive lipids like prostaglandins, which play roles in inflammation and pain regulation. Saturated versus unsaturated fatty acids. Fatty acids can be classified as saturated or no double bonds or unsaturated or containing double bonds. This impacts their physical properties and physiological effects. Saturated fatty acids have straight hydrocarbon chains with all single bonds and are typically solid at room temperature and are associated with increased cardiovascular disease risk while unsaturated fatty acids have one or more double bonds in their chains, are usually liquid at room temperature, and include monounsaturated and polyunsaturated fats that offer health benefits. Physiological significance of lipids. Energy storage. Lipids, especially triglycerides, store energy efficiently and serves as a long-term energy reserve. Cell membrane structure. Phospholipids are crucial for cell membrane integrity and function, regulating the passage of substances into and out of the cells. Hormone synthesis. Lipids, particularly cholesterol, are precursors for the synthesis of steroid hormones, including sex hormones and corticosteroids. Insulation. Adipose tissue, a lipid-rich tissue, provides thermal insulation, helping maintain body temperature. Protection of organs. Adipose tissue also acts as a cushion, protecting vital organs from physical damage. Fat-soluble vitamins. Lipids facilitate the absorption and transport of fat-soluble vitamins like vitamin A, D, E, and K in the body. Physiological significance of lipids. Clinical relevance of lipid metabolism. Energy storage. Lipids are essential for storing and providing energy, making them relevant in conditions like obesity and diabetes. Cell membrane structure. Lipids are a key component of cell membranes, influencing drug absorption and efficacy. Cholesterol metabolism. Dysregulation can lead to atherosclerosis, requiring lipid-lowering drugs. Prostaglandins. Lipid-derived signaling molecules impact inflammation and pain, relevant to anti-inflammatory drugs. Lipid-lowering medications. Statins target lipid metabolism to reduce cardiovascular risk. Genetic disorders. Inborn errors of lipid metabolism require specialized pharmaceutical interventions. Metabolic syndrome. Lipid metabolism is linked to this complex condition, guiding treatment strategies. Lipid nanoparticles, used for drug delivery, enhancing bioavailability and targeting specific tissues. Phospholipid bilayers, crucial in drug formulation and delivery systems. Importance of essential fatty acids for overall health. Cell membrane function. Essential fatty acids, such as omega 3 and omega 6, are integral to maintaining the structure and fluidity of cell membranes. This is vital for proper cellular signaling and communication. Brain health. Omega 3 fatty acids, particularly docosahexaenoic acid, are essential for brain development and cognitive function. They play a role in memory and mood regulation. Heart health. Omega 3 fatty acids can lower triglycerides, reduce inflammation, and improve blood vessel function, reducing the risk of heart disease. Anti inflammatory properties. Omega 3 fatty acids have anti inflammatory effects, potentially benefiting conditions like arthritis and other inflammatory diseases. Skin and vision. Essential fatty acids contribute to healthy skin and good vision, especially DHA, which is a major component of retinal tissue. Immune system support. Omega 3 fatty acids can modulate immune function and may enhance the body's response to infections. Lipid related health conditions like hyperlipidemia and atherosclerosis. Lipid-related health conditions like hyperlipidemia and atherosclerosis. Hyperlipidemia is a condition characterized by elevated levels of lipids or fats in the blood, including cholesterol and triglycerides. It is a significant risk factor for cardiovascular diseases. Atherosclerosis is a progressive condition in which fatty deposits, known as plaques, build up on the inner walls of arteries, narrowing and potentially blocking blood flow. This can lead to various cardiovascular problems such as heart attacks and strokes. Lipid profiles are essential in diagnosing and managing conditions like hyperlipidemia and atherosclerosis. They provide valuable information about an individual's lipid levels, helping healthcare professionals make informed decisions for treatment and prevention. Thank you.